as far as I'm going to get this weekend, because I'm going to take a little time off. So the idea here, this is the air intake manifold. I'm going to drill some 4-inch holes. One, I think I could probably get 2 here, 2, 3, 4. Let's see if I have one of those things. So 4 of these guys. So yeah, I could fit 2. 1, 2, 3, and 4. So I'll drill the 4-inch hole, and then I'll plastic weld this flange onto this surface. We'll see how that works. I don't know, this type of plastic, I don't think this is high density polyethylene. Anyway, so the idea here would be to finish the top off. The top piece is going to be designed in such a way that it will slide in and out of a groove. Some plastic pieces in the ceiling, almost like an L channel on either side, attached into the ceiling with butterfly clips. And then the intake will have a lip on either side, and this will just slide into place. The reason for that would be so that I can take this in and out and wash it out very easily. It's all plastic welded on the inside. The hardest weld was this weld on the inside, welding this back edge. So retrospectively, what I would have done is, what I would do in the future would be to dimension the part, the workpiece, such that I can move the welding torch inside and get a nice clean weld on the inside, because that didn't work out too well. If this was just a little bit longer and maybe a little bit higher, then the torch, I could have maneuvered the torch in here and done a better job. But it's sealed on the inside and on the outside. Welds on the outside there. There's a HEPA filter, which is going to slide in like so. So the next steps here would be to complete the top with the flange, weld the top on, complete the assembly in the ceiling within the lab, and then create out of 1/8-inch plastic just a component that will fit around the filter to fill this gap up in here with a little handle on it, right? So that I can pull the filter in and out. And that piece will have to be, probably put a gasket on that piece so that it seals in here nicely. And then the idea would be, here, let's see if I can do this, put my camera down inside the lab. Just bring this in. So the exhaust fan is not installed, it's just loosely in place. It's not bolted, it's not wired in. This opening is just, it's not welded yet, so I'm gonna weld all these seams and finish that off. But the idea will be, put my camera down right here. So the exhaust is gonna hook up to this flange here, like so, and then it's going to just slide into an L channel in the ceiling. Maybe I'll thread that L channel so that I can put a couple fasteners in there, and then 1, 2, 3, 4 intakes with the blast gates and the 4-inch pipe. And that will complete that intake. So I'll use this pipe here. I've got enough of it to run from the manifold to a tank, and then at the tank, most likely what I'll do is build something, just a lid that is also a hood. So the 4-inch will weld into the center. Probably use 1/8-inch plastic piece for the piece for the outer edge, piece for the top. Anyway, I'll have to figure that out. I could also buy these from Uline, but it will be cheaper for me to build the stuff from plastic. Now that I can weld, I can build stuff much cheaper. All right, there's how things are looking. A little cleaner in here, but still in the construction phase. This was a real pain to get into this opening. I have to keep this piece here, up here, removable, because I have a stove line and some services in my house that I may need to access at some point. So on the outside, what I've done here is I welded an 8-inch pipe to fit the OD of this blower outlet. So now what happens, the blower will just slide right into that pipe there, and next steps will be to weld this pipe. So I'm going to take this off, weld here, and then just weld a whole bunch of stuff within this opening. Right, like weld these seams. That's quite a big gap there, so I'll have to, you know, play around with that, but I think I can weld that. Got a piece of plastic for here, piece of plastic for here. Then I got the hard wire. So next week, I'll finish this. Next week, this exhaust system will be finished. And that will sort of cap off a very long, it was almost been 5-month process. Refinishing the lab, my basement, a whole bunch of other things around my house. I'm very close to finishing. All right. Plastic welding setup works really nice. I took a whole bunch of footage which I can include in this video. Something that's very helpful is to have these quick connects. So I can quick connect my plastic setup. That way, I'll just show you real quick. So this is what comes with the plastic welding kit. You get a speed welding tip. Sorry, not a speed welding tip, a tacking tip. So this is the most basic welding tip. These you have to buy extra, these speed welding tips. 3/16, 1/4 inch. You buy a tip according to the size of wire that you're welding. Okay? These are expensive. I think these are about $175 a piece. These speed welding tips come with a little cleaner, right? So you can clean out the plastic while you let things cool down. And then it also comes with, and I think this kit cost me, I'll show you the bill, but I think this kit cost me about $500. So it comes with about 10 feet of air line, and there is electrical running through this air line to your torch. So this is what plugs into your air compressor. It does not come with a quick connect. So my recommendation would be to install a quick connect here, because if you imagine threading anything onto all of this is going to put too much strain on these connections, specifically where the hose connects to this T. This does not seem like a very strong connection. You got to be careful with this. I might even tape this up, strengthen it up just a little bit more. Another point with the welding, you should plug this into a separate outlet, your heat into a separate outlet from your compressor. If you don't have an outlet that's got you know, the amperage required to run a compressor and the heating element at the same time. It will work, but at some point it's going to shut off on you, and it's going to shut off at a time when you don't want it to, you know, mid-weld. Okay, so this comes with the setup. This I just quick connect. I'll just show you real quick. All I gotta do is, to get plastic welding, is just quick connect and then plug it in here. You can see I got the compressor and this plugged in the same thing. It will work, but for example, I had things plugged into this power bar here, and it got real hot. You could see it lighten up. So just take consideration of the power. It's very helpful to have a pre-filter like this. You do build up quite a bit of moisture. I don't know if it's because it's so humid out right now. quite a bit of moisture. I should remember here to just open up the valves on my compressor, and I'm going to run this for a minute or two just to get the moisture out of the tanks, but I won't do that yet. Okay, so quick connect here to the plastic welding setup. So as you can see, it's fairly quick and easy to set all of this up, right? This is all, it's, so these things do not come with the plastic welding kit. You gotta buy this. Home Depot sells it. Quick connects, male, female, all these thread adapters. All right, here's the booklet that comes with the plastic welding. So maybe I'll read this, make a video. The most important thing you need to remember though, with the plastic welding, if you just bear with me for 1 minute. The most important thing to remember is the acronym PAST. Okay, that's pressure, angle, speed, temperature. Okay, pressure, angle, speed, temperature. Basically what that means is the air pressure coming out of your compressor needs to be between 2.5 and 3 psi. So you have to have an air compressor that will maintain up to 2.5 to 3 psi. This compressor, I would say once it reaches maximum pressure, which is 200, it will shut off and it won't run for a minute or two. That's about as much reserve as it has to keep up with the plastic welding. So you need a good oilless air compressor that will maintain 2.5 to 3 cubic feet, or sorry, 2.5 to 3 psi, which you're going to read out on the gauge they provide with the plastic welding kit. They provide this gauge and this regulator. This I bought separately to keep the air going into the system nice and clean. And I also find it's much easier to regulate the PSI, my pressure, from here. This, I don't know if there's something wrong with it, but this particular knob just doesn't really seem to do much. Okay, so you got your pressure. That is the pressure coming out of the tank, as well as the pressure you apply to the welding wire as you are welding. Okay, the angle is the angle of the actual torch while you're welding. The speed is pretty self-explanatory. How fast are you welding? So if you go too fast, the plastic is not going to melt enough, and it won't bond to the workpiece. So you need to control your speed and have the temperature. You know, the temperature and the speed are sort of related. The faster you go, the lower the temperature will be. So you need to balance your speed and your temperature in order to get a nice consistent weld. Okay, so they reiterate that the 4 essentials for making better plastic welds: temperature, pressure, angle, speed. And here you can see in this image the angle. When they refer to angle, they're referring to the angle of the torch relative to the workpiece. And for each metal, the angle differs. Okay? So I think I'm going to end the video here. You can see they're showing the angle. PVC, you see PVC, you're pressing it down at a 90-degree. Torch here, this is a speed welding tip, or this is a tacking tip, the standard tip. Tacking tip is heating up the plastic and the workpiece, and then you're pressing. So this is your pressure component. The pressure component, I think it's twofold. One, the air pressure. Two, the pressure on the wire. The pressure you're pressing on the wire here, okay? Polyethylene, you can see you're gonna bond it at a different angle. Each metal is gonna have a slightly different angle, speed, temperature. All right, the speed welding tip is very helpful. In all these images, they are showing it with the tacking tip. This is what I used, the speed welding tip, where you feed your plastic wire through one section of the tip, and then the heat is directed in front of the weld through this nozzle, and the heat is also directed to the plastic. So the plastic kind of melts. It's very similar to hot glue. So you don't want it to be too melty. You're gonna have a messy weld. You don't want it to be too solid. It's not gonna bond. All right. So you can see, I'll show you sort of a good weld and a bad weld. So here, this is a pretty good, consistent weld, whereas here, this is kind of a bumpy, inconsistent weld. And the reason for that would be my workpiece was not positioned the best. The way the piece was sitting was not, it was not cut or squared off ideally. Okay? But this will function. So that's it. Still gotta build the top with the flange. There it is. Plastic welding.